Thank you so much for coming. My name is Ava Forsythe, and this is my STEM project's final presentation. First, I wanted to talk a little bit about me. So I am a senior here at Grandview, and I plan to major in mechanical engineering in college. The first STEM class that I ever took was Engineering Technology 1, and I liked it so much that I decided to take computer-aided design over the summer. And later that same summer, I did an internship at US Engineering as a Revit technician. Some of the clubs that I'm in are Spanish Honor Society, NHS, Key Club, and I also play tennis for Grandview. So I wanted to do STEM projects because I really wanted to challenge myself this year to work on a project for like about 7 months in the STEM-related field. I also wanted to work in a class that was pretty different from a lot of other classes. You go into STEM projects, Mr. Combs will do a little walkthrough of the objectives for the day, and then you have the rest of the period to do what you need to do and get your project done. I also chose my project because it brought together two things that I really liked, which was drones and security. So my project is a pharmaceutical drone delivery system called AeroCare. So basically the drone delivers medicine to people's houses, and the process is through a drone, a drop box, and a carrier, which I'll get more into depth later. So the inspiration behind the project was for Christmas a couple years ago, I got a drone and I really liked it. I wasn't super great at flying it, but I just thought the fact that there was something up there flying in the air, no matter how shifty it was pretty cool. And instead of focusing on building a drone, I wanted to focus more on what a drone could do and how it could benefit society. And some of the things that I focused on with my project was medical delivery. And this could be especially helpful for people living in isolated areas who don't always live right next to pharmacies, but also for elderly and disabled people who aren't always able to go into the pharmacy whenever they need. Drone delivery could be really beneficial for them. So here is my company logo. It is the big blue A, and the arrow in the middle of the A is kind of play on with the word AeroCare. And the blue represents safety, security, and stability, which I wanted when people to think of getting their medicine delivered to them through drone, I want them to think of safety, security, and that's also represented in the name AeroCare. So I couldn't have done this project alone. I had a wonderful expert advisor, Michael Holden. He is a professor of mechanical engineering at California Maritime Academy. He also graduated from Stanford with a doctorate in aerospace engineering, and he helped me with a lot of the technical parts of my program, including the drone and making the actual codes. I also had some really great support advisors. I had my dad. He was good for financial and emotional support. He was also a PA, so he was helpful with the more medical side of my project. Same with my mom. She was there, really helpful, and she is a marketing director, so she was able to help me with the overall look of my presentation to make sure it looked pretty professional. I also had Ryan Pritchell, and he was an idea innovator and SolidWorks specialist. We often bounced ideas back and forth, and he was really helpful with coming up with alternative solutions and fun ideas. I also had Parker Gust. He was my logo specialist. He helped me make the AeroCare logo, and he's also really good at programming. And then I have Shruti Malasetti, and she was my motivator and emotional support throughout this year. She was super helpful and supportive of my project. So the objectives for my project. So I had 6 full objectives that I wanted to complete by the end of the year. The first one was I wanted to become better at researching. The only research I've really done is for English essays, and the research that I'd be doing for this class was a lot more in-depth because I'd actually be creating something and building it. So I was kind of entering a whole new world of research, and I knew that it could benefit me a lot as a mechanical engineer, and so I was able to learn a lot with research throughout my project. I also wanted to learn time management. Because it was a year-long project, it wasn't anything you could save for the last couple of weeks, unfortunately. So I had to try to portion out everything as much as I could. And you'll kind of see how that went a little later on. But finally, I wanted to follow through with the project despite issues that would come up. it's kind of easy to quit when things go wrong because you're like, why would I even want to finish it? But because this was a class and I had a deadline I did need to finish, and so that was something that I was really working toward in working my project. Finally, I want to develop better public speaking skills. I don't go up and present a lot, so I wanted to work on it. We'll see how that goes. Number 5, I want to learn to collaborate on a project. All of the projects that I work on are usually solo. It's just me by myself doing my own thing. So I thought it would be really interesting to use other people's ideas and collaborate with my project. And then finally, I want to officially communicate any needs that came up. Sometimes when I have conflicts that arise, I try to work on it by myself and kind of push it aside. But with this project, I can't just push aside those problems. You have to address them. So I often contact a lot of my advisors, and they help me out. So my final outcome goals. Number 1, I wanted to program a flight path for a telodrome. And I wanted to create a carrier and drop box that could receive and drop off a package efficiently and securely. And finally, I wanted to have a final presentation and a poster board that displayed the process of my project. And then I also had a reach goal, and that was to create a package small enough to fit on the telodrome. And just so you guys know, the telodrome can only carry about 70 grams. So my initial project timeline ended up being really different from what I did by the end of the year. But initially, I wanted, from October to December, I wanted to program the drone and get the flight path all set up and situated. And then I wanted to build and program the drop box and carrier from December to March. And then I wanted, from March to April, I wanted to give myself that whole time to kind of finish my presentation, do a little bit of troubleshooting, and get my project all together. What ended up happening in the end was October, I tested some drone flight paths, which is kind of similar, but I was done within a month. And by November through December, I was able to create a one-motor RFID system, and I'll kind of go more into what an RFID system is later on. But from January to February, I built and printed my carrier, and from February to March, I created a two-motor RFID system. And finally, I was able, from March to April, to assemble both the Dropbox and carrier and finish my presentation. So my project breakdown. So my project has 3 parts and 4 phases. And you'll see, first we have the drone. So the drone that I used is a telodrome, and I wanted to have a drone that could transport a package efficiently. And finally, I wanted to I have a carrier, and this would be the thing that the drone is carrying, and which holds the package inside. And then I want to have the drop box, and the drop box would receive the package from the carrier, and this would be located at the consumer's house. So my first phase, I had the drone. So the research for the drone, I wanted to find a drone that was relatively inexpensive. It also could be programmable and was efficiently worked. I also wanted a drone that could carry a package, but after doing some research, I found those drones cost thousands of dollars, which is something I didn't really have. So I ended up using a telodrone, which is a very small programmable drone that can be programmed with Python and Scratch. And although it can't carry a lot, it was kind of more for proof of concept, and my advisor helped me pick this one out too. So the research for the drone programming, so I started off using Python. But the issue I found with that was it used velocities when I was watching the YouTube videos, and I wanted to program it with distance instead of using velocity. So I switched to Scratch, and it didn't really work. So the code itself was fine, but anytime I plugged it into the telodrome, it landed in extremely different spots. It would go in full-on different directions that I did not have in the program at all. I'm going to say that was more of the drone's issue than my issue, but I don't know what happened there. In the end, the drone was still able to fly, and at the bottom you can see there's something taped to it that is an RFID tag, so in a way it did carry a package. Was it a medical package? No, but it was something that was attached to the bottom. So again, the problems that I had was it was shifty, it wasn't really accurate. Again, it would land in really different spots each time. The reader occasionally got blocked. When I put the first RFID tag on it, it was a card, and it blocked the readers, the sensors, on the drone. And and that resulted in my drone crashing, so I had to exchange for another one. And so with this new one, I made sure that the sensors were blocked. And then my new drone also crashed, and so only the propellers flew off, so I was able to kind of put them back on. But it was really hard in the house with heavy walls not to have it crash into something. But yeah, so that was my issues there. And then for phase 2, I was working with RFID systems, and here's what I wanted for my project. I wanted the delivery to be a no-contact delivery, and this means like physical contact. There can be communication during the delivery, but I didn't want anything to be landing directly on anything else with how shifty drones can be. So what is an RFID system? It stands for Radio Frequency Identification, and basically you might know this when you go to a hotel and you get a key card, and you go up to your door and you click it on the door and it unlocks it. That's basically an RFID system. You have a reader that detects a tag, and it's able to do actions based off of that. So what you have here is you have the RFID tag right here, and inside it is this kind of like copper coil, which allows the RFID reader, and this one I use is a PM5180, to detect the card, and through that it is able to go and tell, like through a logic converter, and Arduino is able to go ahead and tell the motor that when this card is detected, the motor is going to move a certain angle. So the research that I had to do with this was I had no experience in coding or any electrical systems at all. So I was only able to learn about this through my advisor and lots of YouTube videos. But I found that the components I needed were a motor, an Arduino Uno, a logic converter, a PN5180, some batteries that I needed to use, and especially the rechargeable battery was really important to help save money. And then, yeah, I learned to program basically through YouTube videos. And those are the different pieces. So the coding that I use for this, the PN5180 is a specific type of RFID reader that can read from a 15 to 25 centimeter range, which is a lot bigger than some other RFID readers, so I chose this one for that reason. Unfortunately, there wasn't a lot of research online about it, but I did, however, find a GitHub library by A. Chapman that had all the information I needed for the PN5180, so I was able to code with that. And after several trials, the code was successful, so that was good for me. Anytime anything worked in this class, it was a really good day. So, okay, that one's not working, but here's an example of the system working. You can kind of see that when the card is in range, the motors turn. That's exactly what I wanted. And it's about like a couple centimeter range, which is good. So, the setbacks that I had for my system. Well, in that picture, you can see there's a little burn over here. This happened due to the program that I ran, and it was super intense, and it ended up burning the motor. So that was an issue that I had. And then I was also not great at soldering. I've never done it before either. And the first solder iron I used was from my grandpa, and it was a really thick one. And I unknowingly burned a lot of the pieces that I used, and I didn't realize later until the code didn't work. And I didn't understand what was going wrong until I looked at the back, and there are several burn marks. So I had to go order some new parts, and finally I was able to set up some more systems. And then I burned another motor, and this one was bad because this was about 2 weeks before my presentation, and it took a while to get the motors in. But one big thing that I did was when I burned that first motor, I had to order, it was probably like 3 weeks maybe before this presentation, I had to order another motor. Well, I decided to order 2 motors because I knew it was in my capabilities to burn another motor, and that's exactly what happened. So I had an extra motor that I was able to use. Then phase 3 is my carrier. So I built the carrier on SolidWorks. I didn't really need a lot of research for it just because I had a picture of what I wanted it to look like. Basically, it has 2 doors right here, 2 swing doors. And I made this myself and basically put that servo motor right in there. And as it turns the door with it. The only downside of this was that printing this took about 5 days. And so that was really hard, 5 days to come into class, and it was still printing my piece. So I'm sorry, Mr. Combs, for that. And then here's a little video of it working. You can see the card getting close, and then the doors open. And then they close with a little bit of a delay, just to have some extra space in case of error. And then phase 4 was my Dropbox. So I had to do research on basically how to make the swing door system, and this one we needed a one-motor RFID system. So I also had to do research on the sizing of the components. But here you can see this was my before. It's pretty rough. I taped everything. I don't know why, but so it moved kind of a little shifty as well. But by the end, I was able to have it looking a lot more like neat, and it was all black, which I thought was good for presentation. So for the Dropbox, I ordered 2 boxes online that had a security feature of a lock, and I went to the workshop and I made a lot of openings for them so that they could connect. And then I created the top frame on SolidWorks, and I also put my logo on it just for a fun little effect. And so here are the issues that I had with the Dropbox system. So one of them was that the motors moved super quickly. And that was fine for the carrier with the doors, but for the Dropbox, because I had taped everything and it was all hot glued, having it move super quickly was going to test the integrity of it. So it was really fast. It just like slammed right down. And so I went back, I did some crazy glue and some super glue. I took out all the hot glue, and I was also able to find some code to slow down the motor, and that took a lot longer. It took me about a week to try to find out how to slow down the motor. I don't know why it took that long, but I was able to finally slow it down. You can see it there. That's the speed I wanted it, which was good for me. And so finally, my initial reach goal was to create a package small enough that the drone could carry. My final reach goal was maybe I a little bit did it with that little blue tag, but I kind of moved into a different space, and I actually decided to insulate both of my Dropbox and carrier, because I thought that made it more professional and it could maintain the temperature of the medicine. So that was kind of my new reach goal. And basically how the system works is, so you have the carrier up here, and it has an RFID tag. It has an RFID tag here and the reader here, and then it has the same thing down here in the Dropbox, except switched. And because of the orientation of the RFID reader, it can't read something that's really that's close to it horizontally, but it can read more vertically. So there wasn't any interferences between these two, but rather when this came down and got into the range of the Dropbox, these were able to read each other, and because of this, the motor systems put into it, the doors were able to open and the package delivered. So here I have a little final product demonstration. I don't know if you can see a little bit. There it drops. And then when it's out of range, the doors close back up. And then you can open that bottom drawer, and then there's the package right there. And you can kind of see that as well here. Here you have it's lock protected, so only the consumer will be able to access the medical package, which is good. It keeps it safe and secure. So you have the medicine right here, and then I also insulated, as you can see, I insulated this as well. I insulated both the electrical and package carrying side of it, just so that the medicine would mostly stay at the temperature that it needed to be. Yeah, and that's basically my final project. Any questions? Yeah.
So I know you said that like the Hello drone was kind of a smaller thing, a smaller proof of concept. Do you think if you were to upgrade to a larger drone, that would change the design of the drone? So what would you do?
Yeah, one thing I would definitely have changed is the size of the carrier. I kind of realized it didn't need to be that big, but if you had more of an industrial drone, it could definitely carry, if you use some more lightweight material, it could definitely carry the carrier.
What's the maximum size of the package?
About this big. With most medical packages, they're pretty small, so most everything could probably fit in here, especially since Medical packages are pretty lightweight, so there wouldn't really be an issue with that. If it was some sort of different delivery system focused on something else, then there would probably be an issue.
If you had two different medicines that needed to be carried at two different temperatures, would you have to use different drop boxes?
Yeah, I actually I was thinking if I were to kind of go further with this, I could kind of compartmentalize like different and split it into two different sections and do that as well, but that would be like a more future reach goal, but it's possible.
Over the course of this project, did you ever look into getting an FAA Part 107 or looked into any of the kind of new rules about one-to-many drone operation?
No, I did not.
Are there any concerns with different weather conditions affecting the Dropbox or carrier?
No, so basically the good thing about this is because it's insulated, if there are colder temperatures or warmer temperatures outside, it will mostly maintain the temperature of the package inside as well. These two are pretty water resistant, so I wouldn't have, if it was raining or snowing a little bit, it wouldn't be a super big issue. It should maintain the package pretty well.
All right, excellent. Thank you so much. So my group, let's get back to our tables, and those who want to stay, come on around and have more discussion. Well, the next presentation in about 15 minutes.